Hello students, today we are going to discuss the secondary treatment of sewage. Now we will start the secondary treatment by trickling filter. That is the first method of secondary treatment, that is the trickling filter. Now the decomposition of organic matter and resultant purification of the sewage is brought about by a population of microorganisms. Now, microorganisms and bacteria which are naturally present in sewage get attached to the filter media. Organic matter from the sewage influent is also adsorbed on the biological film which is formed by the microorganism around the filtering media particle. Now what will happen? We generally allow the water from the primary sedimentation tank to come to the top of the thickening filter like this from the central column portion, and it will be distributed over this sand filter media whose diameter is 30 to 60 meter and whose height is 1.8 to 2.4 meter in the percolating form from the nozzles which is provided at the top of the sand filter. Okay, now these all nozzles will be in rotating form and this will be done by the revolving head. Okay, now guide wire is generally provided to hold the nozzles so that it can be revolved in a particular manner over the sand filter. Okay, now water from the primary sedimentation tank will comes into the central column, and from the central column it will comes into the nozzle, and from the nozzle it will reach to the top of the sand filter like this. Okay, now with the help of air pipe we generally provide air, or we generally supplied air into that trickling filter. Now this air will be consumed by the microorganism that will be present over the sand filter in the wastewater, and this oxygen is generally used by that microorganism for the decomposition of organic matter, and this layer of combined microorganism and organic matter will be known as slime layer. This is known as slime layer. Clear? Now due to continuous coming of sewage water over the sand filter, the layer thickness will goes on increasing like this, and when there will be sufficient thickness of the slime layer over the sand filter, what will happen? All the air will be consumed by the top microorganism for the decomposition of the organic matter. It means that the supplied oxygen is totally consumed by the top microorganism for the decomposition of organic matter, and at the bottom of the slime layer there will be anaerobic environment. There will be anaerobic environment. Due to this anaerobic environment as well as mass of the top layers, what will happen? The slime layer loses strength and from the bottom it will break like this, and this process of breaking of slime layer is known as slowing of slime layer. This is known as slowing of slime layer. Clear? Now due to this breaking of slime layer, the decomposed organic matter will comes into the filter media, and from the filter media it will reach to the central effluent, and from the central effluent it will be sent to the secondary sedimentation tank, and in the secondary sedimentation tank all the decomposed organic matter will settle down and the resultant water will be free from the organic matter. That is the complete working of thickening filter. Okay, now that is the actual diagram of thickening filter which is generally circular in shape. Okay, now the process or phenomena is also called as attached growth process, because in this process the microorganism and organic matter will attach to the sand layer. That's why it is known as attached growth process. Okay, now efficiency is generally given by influent BOD minus effluent BOD upon influent BOD into 100. Here SI is the influent BOD, SE is the effluent BOD. The BOD in the outgoing water is known as effluent BOD, and the BOD in the incoming water is known as influent BOD. Divided by influent BOD into 100 will be the efficiency according to the Indian formula. But if in question they want us to calculate the efficiency of the trickling filter and no formula is mentioned or no method is mentioned, then we will go for the NRC equation, that is the National Research Council of US equation, which will be given as 100 upon 1 plus 0.44 U, where U is the organic loading in kg per meter cube per day. Generally we need to put the value of U in kg per meter cube per day, and it will be equals to discharge into influent BOD divided by volume of trickling filter. Clear to all? Now we will go for the next process, that is the activated sludge process, which is one of the most important secondary treatment unit of sewage treatment. Okay. Now in activated sludge process provides an excellent method of treating either raw sewage or more generally the settled sewage. Now the sewage effluent from primary sedimentation tank, which is thus normally utilized in this process, is mixed with 20 to 30% of own volume of activated sludge, which contains a large concentration of highly active aerobic microorganism. Now this mixture enters an aeration tank where the microorganism and the sewage are intimately mixed together with a large quantity of air for about 4 to 8 hours. So that will be the detention time, that is 4 to 8 hours. Under this condition, the moving organism will oxidize, that is the microorganism will oxidize the organic matter, and the suspended and colloidal matter tend to coagulate and form a precipitate which settles down in the secondary settling tank. Now its complete figure is shown here, that is the raw water. It is supplied to an aeration tank where we supplied large amount of air so that all the microorganism will come in the activated form. Now when this microorganism will come in the activated form, we will send this water to the secondary clarifier where the charged microorganism will decompose all the organic matter, and the organic matter will be removed in the form of sludge like this. Okay. Now from the 100% sludge, 30% is returned to the process again in the form of sludge recirculation, and 70% is sent to the sludge digester. Okay. And the remaining water, which will be pure or which will be free from the organic matter, will be sent to the disposal in the natural water resources. Clear? Now we will see how the activated sludge process will work. Okay. Now this is the working of activated sludge process. In the activated sludge, we generally supplied Q amount of water which is having BOD Y naught. Now during the supply of that water, we just provide large amount of air in the aeration tank so that all the microorganisms will come in the activated form. Now V is the volume of the aeration tank, XT is the concentration of MLSs. It means that MLSs full form is mixed liquor suspended solids. Okay, mixed liquor suspended solids. It means that the suspended solid which will be in the liquid form, or the suspended solid which will be present in the liquid mixed form. Okay. Now why is the BOD of the water which is in the aeration tank? Here the BOD is Y naught air, and here the BOD is Y. I will tell you why the BOD is changed from the initial to the aeration tank. Now from this aeration tank, we just supply the water to the secondary clarifier where all the decomposition will taking place. Okay. Now why the process named as activated sludge? Because this process will not work as effectively as possible until we supplied the return sludge to the process. Okay. So if we start the new activated sludge process in a particular place, so we need to provide the returned sludge from another activated sludge unit. Okay, we will take the activated sludge from the another activated sludge unit and we will mix it with the inflow water. That's why our process is known as activated sludge process, and due to this returned sludge the process will become fast and well done effectively, okay, and efficiently. So the returned sludge will be QR, which we need to provide here, and it will contain the concentration of solids as XR. So the total amount of water supplied to the aeration tank is Q plus QR. So the amount of water which will be coming out from the aeration tank is Q plus QR. Now in this return sludge there will be decomposed organic matter and the charged microorganisms. So the charged microorganism will do what? It will decompose some of the organic matter. That's why the BOD is changed from Y0 to Y. Clear? Now this BOD will move to the further in the secondary clarifier, and the MLS is XT, that is the concentration of mixed liquid suspended solids. Now in the secondary clarifier all the decomposition of organic matter will takes place with by the help of microorganism, and all the decomposed organic matter will be sent to the downward journey as sludge, now from this activated sludge, why we called it as activated sludge? Because in this sludge the microorganism will be present in charged form. It means that they have enough amount of oxygen that if they will mixed with another type of organic matter, they will do the decomposition of that organic matter fastly. So they are known as activated microorganism. That's why that sludge is known as activated sludge, because they will contain activated microorganism as well as decomposed organic matter. Now from this activated sludge we just supply the 30% of sludge in the process again, and the 70% is sent to the sludge digester. Okay, now the water which will be present in the secondary clarifier will be sent as effluent for the disposal in the natural water body, and it will contain the discharge as Q minus QW. It will be equals to Q minus QW, because QW is supplied to the system. Okay, sorry, QR is supplied to the system, so the total discharge will be Q plus QR. And when the water is coming from the bottom of the secondary clarifier, it will be equals to QR plus QW. QW is the wasted sludge which is sent to the sludge digester, and QR is again sent to the process. Okay, so the net discharge coming out as effluent will be equals to Q minus QW only, and the BOD of that effluent will be very less, that will be indicated by YE, and the suspended solid will also be very less, and it will be indicated by XE. So that will be the complete activated sludge process. In this we just supply a sewage water which is having discharge of Q and having BOD of Y. At the initial phase we just add a returned sludge here whose amount is QR and whose suspended solids concentration is, or the solid concentration is, XR. Okay, now when this activated sludge is mixed with the inflow water, what will happen? The charged microorganism will do some of the decomposition of organic matter in this aeration tank only. That's why the BOD will be changed from Y0 to Y. And in the aeration tank we just provide large amount of air to the microorganisms so that they will become charged and they will do the decomposition of organic matter in the secondary clarifier. Now we will send that water from the aeration tank to the secondary clarifier where the decomposition will take place, and all the decomposed mass will be taken out from the bottom of the secondary clarifier as activated sludge. From that 30% will be sent back to the process and 70% will be taken out as wasted sludge. Now the effluent water will be taken here and its discharge value will be equals to Q minus QW, and YE is the effluent BOD and XE is the concentration of suspended solids in the effluent water. Okay, now that will be the activated sludge process. Clear to all? Now the settled sludge called activated sludge is then recycled to the head of the aeration tank to be mixed again with the sewage is continuously being produced by this process, and a portion of it being utilized and sent back to the aeration tank, whereas the excess portion is disposed of properly along with the sludge collected during the primary treatment. After digestion, the effluent obtained from a properly operated activated sludge plant is of high quality, usually having a lower BOD removal. Okay, is BOD removal is up to 80 to 95%, and bacteria removal is up to 90 to 95%. It means that it have a very high BOD removal of the order of 80 to 95%, and bacteria removal is up to 90 to 95%. Clear to all? Now we had already discussed the complete process of activated sludge. Now we can move to the further process, that is the calculation of various parameters, that is aeration period, hydraulic retention time, sludge age, mean cell residence time, and so many more parameters. Now detention period can be determined by just dividing the volume of tank or the volume of aeration tank by the rate of sewage flow in the tank or the amount of sewage flow as inflow. Okay, now the volume of aeration tank will be V and the amount of water sent as inflow water will be Q. Now its unit will be day, but we want the aeration time or the detention period in hours. So we just convert this day into hour by multiplying with 24. That will be the aeration period or hydraulic retention time. Now the next will be the sludge age or mean cell residence time. It is the average time for which biomass stays in the system is called the sludge age or mean cell residence time. Now we want to calculate the mean cell residence time, for which we need to divide the total biomass in the system divided by the biomass living per day. Now the total biomass which will be present in the system is xt, and it will be in milligram per liter. It means that xt is the amount of biomass present in milligram in 1 liter of water or 1 liter of sewage water. Now we need the complete biomass in the system, so we need to multiply the xt by the volume of aeration tank. That will be the total biomass in the system. Now the biomass living per day will be equals to what? Biomass living is as effluent form and in the wasted sludge form, that is QW. Okay, now we just multiply the amount of solid with the total water wasted, that is XR into QW. Similarly, XE into Q minus QW, that will be the effluent water. Okay, now we get the value of sludge age or mean cell residence time from this formula, that is XT into V upon XC into Q minus QW plus XR into QW. Okay, done. Now we will go for the food to microorganism ratio. Now food is generally present in the form of organic matter and mass will be in the form of microorganism. Okay, food will be in the form of organic matter and the microbial mass or microorganism will be in the form of all the microorganisms that will be present in the system. So food will be equals to discharge into the influent BOD, it is Q into Y naught, and the microbial mass will be equals to XT into V. Now we just take the accurate value of food, which will be equals to what? It will be equals to Q into Y naught minus YE, because some organic matter will be going out as the effluent form. So what will be the total food that will be consumed in the process? It will be equals to Y naught minus YE. So we just write the food value as Q into Y naught minus YE here, and it will be divided by XT into V, that is the microbial mass. But YE value is very less, that's why we generally take it as Q into Y naught upon XT into V. But if in question YE is given, then you need to use this equation, that is Q into Y naught minus YE upon XT into V. Otherwise, if YE is not mentioned in the question, then you will use that formula, that is Q into Y naught upon XT into V. Now, lower the F by M value, the higher will be the BOD removal in the plant. Okay, that's why F by M ratio is always less than 1. Suppose that if I will provide you one slice of pizza, okay, and there will be 10 persons who will consume this pizza, then how much time will be taking to completely remove or to completely consume that pizza? The time will be very less because the number of persons are very high and the amount of pizza is very less. That's why the time required for its consumption will be very less. Okay, now if we provide or if I will provide you a 20 pizza in between 10 people, okay, 20 pizza in between 10 people, now what will happen? It will require some time to totally consume this 20 pizza. That's why if food is less and microorganisms are very large, then the process will work effectively. That's why we generally kept F by M ratio less than 1. Now suppose that in place of one pizza, I will provide only a small bite of pizza here, and there will be almost 10% surrounding that bite of pizza. Now, what will happen? They will not consume that pizza and they will flourish over that pizza. It means that they will protect and grow on that pizza. They will not consume that pizza. Similar to our process, if organic matter is very less, then microorganism will not decompose that organic matter and they will flourish over that organic matter. Now if this case will happens in our activated sludge process, then what will happen? Our activated sludge will not form because the decomposition of organic matter is not there. So for the removal of this type of method, we generally add chlorine in the water. Now chlorine generally done the disinfection of that water. It will kill all the microorganism as well as remove all the organic matter. Now all the microorganism and organic matter is removed from the system. Now again we add the water and again the process will be started. Okay. Now that process in which the bacteria or the microorganism will not decompose the organic matter is known as bulking of sludge, and it will take place at a very low F by M ratio, that is 0.3, less than 0.3. So we generally kept the F by M value in between 0.3 to 0.6. Okay, and we had discussed that for the removal of bulking of sludge we add chlorine for its disinfection and is known as chlorination. Clear to all? Now that will be the food to microorganism ratio. Now we will move to the next portion, that is the sludge volume index. Now it represents the degree of concentration of the sludge in the system, hence decide the rate of recycle of sludge required to maintain the desired MLSs and F by M ratio in the aeration tank to achieve the desired degree of purification. Okay, now SVI is defined as the volume occupied in ml by 1 gram of solids in the mixed liquid suspended solids after settling for 30 minutes. Now if you want to calculate the sludge volume index, just take 1 liter of just take 1 liter of mixed liquid suspended solids, and in that solid you will just calculate the amount of suspended solid present in that water in milligram per liter. Okay, it can be calculated by evaporation method. We had already discussed that method also. Okay, now when you determine the suspended solids concentration in that water, now you will take that water, that is 1 liter of MLSs, in a container, in a beaker having graduations on the sides in ml, in ml. Okay, now you just add 1 liter of mixed liquid suspended solid in this container and allow it to remain as it is or remains in stationary condition for 30 minutes. Now during this 30 minutes, all the suspended organic matter will settle down at the bottom like this. All the organic matter will settle down at the bottom like this. Now you will note the volume of the settled solid, that will be in milliliter per liter. So let it be the weight is VOB milligram per liter, or we can just write it as XOB milligram per liter, and the volume will be VOB milliliter per liter. Now we want to calculate the sludge volume index, so it is the ratio of settled sludge volume, that is VOB, divided by the suspended solid concentration in MLSS, that is XOB. So we just divide the VOB upon XOB in milliliter per milligram, because the unit is milliliter per liter and milligram per liter. So after removal of liter to liter, the unit comes out as milliliter per milligram. Now we want answer in milliliter per gram. So it will be equals to VOB upon XOB into 1000. We had converted the milligram into gram, so we need to multiply here 1000, and the unit will be coming as milliliter per gram. Now we generally use, or we generally kept the SVI value very high in the range of 50 to 150 milliliter per gram, and such a value indicate good settling sludge. That will be the sludge volume index. Okay, now we can move to the next important parameter, that is the recirculation ratio. Now what is recirculation ratio? It is the ratio of recycled water to the original water supplied to the system as inflow. So it will be equals to QR upon Q. QR is the amount of water in the recycled form, and Q is the total inflow water. Now if we want to determine the organic loading, we had already discussed in the thickening filter that it will be equals to Q into influent BOD divided by volume. Here the influent BOD will be replaced by Y naught, so organic loading will be equals to Q into Y naught upon V in kg per meter cube per day. Okay, that will be the organic loading, and that will be all about the activated sludge process. Clear to all? Now we can move to the oxidation pond method. Okay, now the oxidation ponds are open flow through earthen basins specifically designed and constructed to treat sewage and biodegradable industrial wastewater. Okay, now what will happen in this oxidation pond? Suppose that we just kept a large pond here in which we will store large amount of sewage water. Okay, now when we store large amount of sewage water in that oxidation pond, sunlight will pass through that sewage water. Now in that sewage water there will be algae present in that, as well as microorganism and organic matter will also be there. Now with the help of this sunlight, the algae performs photosynthesis process and releases oxygen in the oxidation pond water. Okay, now this oxygen is consumed by microorganism, and they will do the decomposition of organic matter, and that microorganism algal combination is known as algal photosynthesis or algal symbiosis. Okay, that is known as algal photosynthesis or algal symbiosis. Due to this symbiosis, the complete decomposition of organic matter is taking place. Okay, now such ponds provide comparatively longer detention period extending from few days to several days, during which time the waste gets stabilized by the action of natural forces. Which type of natural forces? Photosynthetic reactions. In a totally aerobic pond, the stabilization of waste is brought about by aerobic bacteria which flourish in the presence of oxygen. With the help of aerobic bacteria, we can decompose the organic matter. Okay. Now, the oxygen demand of such bacteria in such a pond is met by the combined action of algae and other microorganisms called algal photosynthesis or algal symbiosis, which we had already discussed. Now, in this symbiosis, the algae, which are microscopic plant, while growing in the presence of sunlight, produces oxygen by the action of photosynthesis, and this oxygen is utilized by the bacteria for oxidizing the waste organic matter. Clear? Now the end products of processes are carbon dioxide, ammonia, phosphates, which are required by the algae to grow and continue to produce oxygen. That's why it is known as algal bio photosynthesis or algal symbiosis. Clear? Now, oxidation pond, certain value will be there. Properly operated pond may be as effective as trickling filter in reducing the BOD of sewage. Now, the BOD removal is up to 95% and the coliform removal, that is the bacteria removal, is up to 99% or so. And the minimum depth of water which is kept in that pond will be 0.3 meter, and the depth of oxidation pond is 1 to 1.8 meter, and detention time is 2 to 6 weeks. That is all about the oxidation pond. Now we can move to the aerated lagoons. Now in oxidation pond, the oxygen is supplied by natural means, that is the combination of algae and the sunlight. But if we provide oxygen by mechanical agitation in that stabilization pond or in that oxidation pond, then that pond is known as aerated lagoon. Okay, so I had right here that if oxygen is supplied to the stabilization pond by mechanical agitation, they are termed as aerated lagoons. Clear to all? Okay, now we can move to the next process, that is oxidation ditch. Now we had already discussed the activated sludge process. Now the oxidation ditch is a modified form of extended aeration of activated sludge process. It means that we had extended the aeration time from 4 to 6 hours or from 3 to 4 hours up to 12 to 15 hours. Okay, now it has been a modified to eliminate the primary sedimentation tank and the sludge digestion tank in a process called extended aeration. Here we had already removed the primary sedimentation tank and we will take the water directly from the screening process. Okay, and we will not need any type of sludge digestion or sludge digester tank here. We will directly send the sludge on the drying bed. Okay, now this type of method is known as oxidation ditch, which is known as extended aeration or extended activated sludge process or modified activated sludge process. Here the longer aeration period is provided for the complete decomposition of organic matter, that is known as oxidation ditch. Clear to all? Done. So that is all about the secondary treatment. Okay, now we will see the further treatment in our next classes. Okay, thank you very much, students.